Hello everyone, my name is Ananya P. Tamkar and I am a first year student from Sri Venkateswara College of Engineering. In this video, I shall be talking about applications of double integration to find area and volume in mathematics. What is double integration? Integral of a function in two variables is called a double integration. Here we have an example of double integration. 0 to 2 integration of 0 to 2 to integration of 0 to y x square plus y square into dx into dy. Double integration have many uses in mathematics. They are finding area enclosed by curves in Cartesian and polar form, finding volume of general and irregular solids, finding surface area of solids, and finding volume of solids of revolution. Now let us talk about finding area between two curves. Double integration used to find area between two curves. The integral represents the difference between the curve equations. Here are the formulas which are used to solve various problems. Double integration dx dy is the formula to find area of region R in Cartesian form. Double integration of R into dr into d theta is to find area of region R in polar form. Triple integration is used to find volume of a solid in Cartesian form. Double integration of 2 pi r square sin theta into dr into d theta is to find the volume of solid obtained by the revolution of a curve about the initial line. Now I shall solve a problem to find the area enclosed by an ellipse by double integration. First, let us draw a rough diagram. Here we have an ellipse. To find the area of the whole ellipse, we can multiply the area enclosed by the ellipse in the first quadrant by 4. With the equation of the ellipse is x square by a square plus y square by b square equals to 1. If we equate the equation for y, we will get b by a into root a square by x square. Hence, y varies from 0 to b by a square minus x square. Now if we assume y is equals to 0, then x square by a square equals to 1 is the equation which we will get. Hence x is equals to 1. Now we get that x varies from 0 to a. Let a be the area enclosed by the ellipse, which is equals to 4 into a1, which is the area enclosed by the ellipse in the first quadrant. We know the formula to find area in Cartesian form is double integration dx by dy. We change the integration order and we get these following limits. So now the equation is a1 is equals to integration of x equals to 0 to a, integration of y equals to 0 to b by a root a square dy by dx. Now we shall integrate a1 is equals to a x to the power 0, x equals to 0 to a. Integration will get y. The upper limit is b by a into a square minus x square by 0 is the lower limit into dx. Now by applying the limits, we shall get b by a square minus x square into dy by dx. We shall take b by a outside, and there is a standard formula to integrate root a square minus x square, that is b by a integration of x equals to 0 to a by x by 2 into a minus x square plus a square by 2 into sine inverse x by a. This is the integration we get. This is the upper limit and this is the lower limit. By applying the limits, we get b by a equals to 0 plus a square into sine inverse of 1. Then we get b by a into a square by 2 into sine inverse 1 is equal to pi by 2. Hence we get pi ab by 4. This is the value of a1. Now we know that area is equals to 4a1. Hence area of the ellipse is equals to pi ab square units. Now let us look at the second equation. This is to find the area enclosed by a curve in polar form. Find by double integration the area enclosed by the curve r equals to a into 1 plus cos theta between theta by equals to 0 and theta equals to pi. So here r varies from 0 to a into 1 plus cos theta, and in the question only it's given theta equals to 0 and 0 to pi. So we know that the equation to find area enclosed by a curve in polar form is double integration A equals to double integration r dr into d theta. Now we have the value of r as a into 1 plus cos theta. So we shall get the equation by applying the limits as theta equals to 0 into pi and r equals to 0 to a 1 plus cos theta into r dr d theta. By integrating, we shall get the following result. Now we know that 1 plus cos theta is equal to 2 cos square theta by 2. Hence, we shall substitute this value. We shall get a square by 2. Let us take a square outside. Theta equals to 0 to pi 2 cos 4 cos to the power of 4 by theta by 2 into d theta. Now let us take theta by 2 as t. If we differentiate this, we shall get 1 by 2 into d theta equals to dt. Now d theta is equal to 2 dt. Now if theta is equals to 0, then t is also equals to 0, and if theta is equals to pi, then t is equals to pi by 2. So now by using this, we can change the limits of the integration. So let us take 4 outside, and we'll get 2 dt. So we will take 2 outside as well. Hence we'll get 4a square pi integration of theta into theta equals to 0 to pi by 2. Sorry, the limit is 0 to pi by 2 into cos to the power of 4t into dt. Now by using reduction formula, we can solve the integration. Now the value of n is equals to 4. Hence we'll get 4a square into n minus 1 is 3 by n, which is 4, into n minus 3 is 1 and n minus 2 is 2, and in pi by, we can multiply by pi by 2 because n is equals to 4 and if which is even, hence k is equals to pi by 2. Hence we shall get the area as 4a square. Hence we shall get the area as 3 by 4 a square into pi square units. By using similar methods which we used in the previous problems, we can also find surface area of various solids. We can use double integration to find the surface area element over a region. It is essential in engineering for design and manufacturing. Now let us look at to finding the volume of solids. Double integration can be applied to irregular shaped 3D objects. It divides a solid into simple volume elements. Some volumes also use double integrals. To find the volume in Cartesian form, we generally use triple integration. This is essential to find measurements of various machines, vehicles, buildings, structures, etc. Now, double integration can also be used to find the volume of solids of revolution. Let's say a curve is rotating about the initial line and it encloses an area. Double integration finds volume by integrating the cross-sectional area of that solid. Now, let us do a simple problem. Find the volume generated by the revolution of a cardioid r equals to a into 1 plus cos theta about the initial line. In this sum, we have a cardioid and it is rotating about the initial line, which is the x-axis. Now, this rotation of the curve forms a solid. We should find the volume enclosed by that solid. We know the formula to find the volume of a solid of revolution. That is double integration of 2 pi r square into sine theta into dr into d theta. R varies from 0 to a into 1 plus cos theta. Now theta varies from 0 to pi. By applying these limits, we get the integrating equation as integration of theta equals to 0 to pi, integration of r equals to 0 to a into 1 plus cos theta into integration of 2 pi r square sine theta into dr into d theta. Now, by solving integration, we'll get. Now, let us integrate this part. We'll get theta equals to 0 to pi into 2 pi by r cubed by 3 into sine theta into d theta. Upper limit is a into 1 plus cos theta and lower limit is 0. Now, by applying the limits, we get. Let's take 2 pi by 3 outside. Theta equals to 0 to pi, and then a cube into 1 plus cos theta whole cube into sine theta into d theta. Now let 1 plus cos theta be equal to t. If we integrate this, we'll get minus sine theta into d theta equals to dt. Now, if theta is equals to 0, then t is equals to 2. And if theta is equals to pi, then t is equals to 0. By using this, we can apply the new limits to the integration equation. 2 pi by 3 into 2 to 0. Let's take a cube outside. Then we'll get t cube into minus dt. Now to get rid of this minus sign, we can simply flip the limits. We'll get 0 to 2 3 t to t cube dt into dt. By integrating this, we'll get t to the power of 4 by 4. Upper limit is 2, lower limit is 0. 2 pi a cube by 3. If we apply the limits, we get 2 to the power of 4, which is 16, and by 4 we'll get 8 pi a cube by 3 cubic units as the volume. Thank you for watching this video. I hope you found this video informative and educational. Don't forget to like the video and subscribe to my channel, and have a nice day.